Alright, so let's get back to our original problem. We were trying to find the antiderivatives of this guy. And what we did is we said, okay, let's take this fraction, see if we can split it up. We're going to guess that it looks like ax plus b over x squared plus 4 plus c over x minus 2 plus d over x plus 2. We figured out our a, b, c, and d. We figured out our a was 0. So we are going to have 0x, which is 0, plus b over x squared plus 4. And our b value was 2. So we're going to have 2 over x squared plus 4. All right, next we have c over x minus 2. Well, we found c to be 1/2. All right, and next we had d over x plus 2. We found d to be negative 1/2. Okay, so now we need to find antiderivatives of these guys. So I'm going to break this integral up to 3 pieces. I'm going to find antiderivatives of this guy. And so on this next one, I got this compound fraction here. That's kind of annoying. I'm going to bring down that 1/2. So I'm going to think of that as 1/2 times 1 over x minus 2. And on this next one, I'm going to take out that negative 1/2. So I have plus negative 1/2 times 1 over x plus 2. All right. So antiderivatives here, not so bad, but it's this one that's going to give us a little trouble. 2 over x squared plus 4. So what you got to think about is, well, what does that look like? To me, this looks a lot like 1 over x squared plus 1, which is the derivative of tan inverse. So if you're going to use my method, what you're going to do is you're going to say, well, how do we make this guy look like this? How do we make x squared plus 4 look like x squared plus 1? The way we do that is we factor out a 4. So I'm going to factor out a 4 on the bottom. And if you do that, you're going to have x squared over 4 plus 1. Over here, we can just find our antiderivatives. Let's go ahead and do that. I'm going to have natural log absolute value of x minus 2. Over here, let's see, we got a negative 1/2 there. And then natural log absolute value of x plus 2. All right. So now on this guy, oops, forgot my dx. There we go. All right. So for this guy, okay, well, I got a 2 here, I got a 4 here, 2 and 4. You can do a little crossing off. So you'll be left with a 1/2. So I'm going to pull out a 1/2. So 2 over 4 is 1/2, so I'm pulling that aside. And now I got x squared over 4 plus 1. Now remember, my goal was to say, well, I want to make that look like 1 over x squared plus 1. I'm getting close, but not quite. Here I have something squared divided by a number, plus 1. I don't have that here. I have something squared plus 1. So I got to fix that. X squared over 4, I'm going to think of that as x over 2 quantity squared plus 1. All right. And now I have a couple options. I can say, aha, I can do u substitution. I will let u be x over 2. So that is an option. You could let u equal x over 2. You got another option. My personal favorite, the old guess and check method. So you're like, okay, this looks like the derivative of tan inverse of x. The only difference is you have replaced x with x over 2. So here's what my guess is going to be. I'm going to guess here for my antiderivative that I'm going to get tan inverse of x over 2. You got to say, well, is that going to work? You can take a derivative to check. What's the derivative of tan inverse of x over 2? You would get 1 over x plus 2 squared plus 1 times the derivative of the inside, which is 1/2. Oh, aha, great. I did it. It works. But again, you could have done u substitution. These videos are getting long, so I'll skip the u sub, but you can try it on your own. And lastly, don't forget your plus c.